Hi guys, we are going to talk about boundary layer ingestion analysis of the D8 aircraft configuration. We are Aaron Álvarez, Cristian de Anda, and Marcos Vargas. Introduction. In recent years, most industries have focused on the environment, and due to the exponential growth of the world's propulsion, there is a greater demand from products and services which causes a great impact on our environment. The aerospace industry is not left out of this, and is that apart from everything that takes place to produce an aircraft. Actually, the aviation contributes 2% of the gases in our atmosphere that cause global warming, and the need of finding alternative to help aircraft have less impact on the nature. Theoretical background. Boundary layer ingestion, BLI. BLI is a technology to increase the propulsive efficiency of an aircraft by reducing the total drag an aircraft experience in flight and reducing fuel consumption. Allows better utilization of the boundary layer, reducing energy consumption and aircraft noise. N+3 program. In 2008, NASA awarded for research contracts that are part of its N+3 program, known as such because it is looking for three new generation aircraft more advanced than the ones we currently know. The contracts awarded were to teams led by Boeing, Northrop Grumman, GE, and MIT. In this competition, certain objectives were established which consisted of aircraft noise, engine emissions, fuel consumption, and runway length. The 8 aircraft concept. The aircraft configuration analyzed here is the D8 double bubble, named for this characteristic fuselage cross-section. This configuration is based on the modified tube and with a very wide fuselage to provide extra lift. Its low sweep wings reduce drag and weight. The embedded engine sit-aft of wings. The D8 series aircraft will be used for domestic flights and is designed to fly at Mach 0.24, carrying 180 passengers. And the D8 configuration. Fuselage. Its characteristic features are the twin islet cabin in a double bubble cross-section, the upturned nose with a raised cockpit, and the flat rear fuselage. BLI configuration. The BLI configuration has propulsion units embedded in the rear fuselage. Performance metrics for boundary layer ingestion. BLI analysis. BLI performance parameters that are net streamwise force coefficient, net propulsion power coefficient, electrical power coefficient, BLI benefit, and BLI versus non-BLI configuration. And this is a table for non-BLI propulsion power relative to BLI propulsion versus nozzle area at series streamwise force. Aircraft results, aircraft performance, and this table is a performance comparison of the 8.2 aircraft and B737-800 Vaseline. And we have here we have the NASA metric Vaselines, and this the B737-800, the N+3 Golds, and finally the 8.2 aircraft. And the 8 aircraft results. General benefit. Since the beginning of the study for the implementation of this limits layer intake in aircraft, the main objective is to reduce fuel consumption, being this a benefit for both the environment and for the airline that operates the aircraft. Demonstrating in some studies, such as such as NASA with the concept of the A double bubble, that the vehicle can be up to 8.5% more efficient, reducing this percentage of fuel consumption compared to other aircraft used today. But these are not the only benefits that have been found on this new technology. Among them is also considered that it may further the noise produced by aircraft, which is often a major problem and is often a cause from complaints for population living near airports or in cities with heavy air traffic. A study done in Germany showed that 37% of the population feels affected by aircraft noise. And maybe the noise does not seem to us something serious, but the OMS has declared that noise is the second most important population factor because it can cause ear disease, cardiovascular disease, and myocardial infarctions. So the BLI is of utmost importance for this. Also, as another advantage is that in some studies it is also considered that the thing to use the boundary layer could reduce the work generated by the engines of the propellant, as the boundary layer will practically help them to reduce drag. With this is the belief that they could make lighter propeller with which the aircraft will be lighter and thus could perhaps be optimized in material, making the cost in the production of the aircraft is something cheaper. On the other hand, also as a result of research, it has been seen that perhaps it is difficult to be fully efficient VLI, as it is believed from the point of aerodynamic integration, that is that total pressure losses, this being the biggest challenge. And finally, the conclusions. The aerodynamic benefits of BLI is defined as a reduction in mechanical flow power required, and it was quantified with the use of a direct comparison of non-BLI and BLI propulsion installation on the D8 aircraft operating at the same condition. This benefit is mainly due to reduced jet dissipation, which generates a higher propulsion efficiency, a significant fuel burn benefit. Configuration with higher ingestion will have correspondingly more considerable benefits. The aerodynamic benefits of BLI is defined as a reduction in mechanical flow power required, and it was quantified with the use of direction comparison of non-BLI and BLI propulsion installation on the D8 aircraft operating at the same condition. The results obtained can be summarized as it follows. A reduction in jet dissipation because a portion of the fluid entering the propulsion has lower than free steam velocity and thus produce the same force with lower jet velocity. This reduction generates a higher propulsive efficiency, a significant fuel burn benefit, and a reduction in airframe dissipation due to energy added to the wake fluid and the reduction of nasal wetted area. It is shown that it is not unique way to compare BLI and non-BLI propulsion system performance for a given aircraft configuration. The BLI benefits depend on both the amount of boundary layer ingestion and the sizing of the propulsion in each configuration. It is reasonable to assume that configuration with higher ingestion will have correspondingly more considerable benefits. is our reference, and that will be all. Thank you for your attention.